In this chapter, we're looking at chemistry as it pertains to biology. And just to get us started off, the four most common elements that are found in living organisms, living things, are nitrogen, oxygen, carbon, and hydrogen. Those are the four top elements that you'll see in biological molecules. Now, of course, there are other elements, but for the most part, those are the building blocks. Those are the elements that organisms are comprised of or composed of. Something else you're going to want to be aware of is trace elements. Those are elements that are required in a very small amount, such as iodine is a good example. And if you do not have that small amount, it can cause big problems. So even though you need it in a very tiny, tiny amount, if you do not have that tiny amount, it can cause very serious problems in biological organisms. And more detail on iodine is provided in your textbook and in the study guide as well. So take a look. And then you're going to want to have a good understanding of subatomic particles, the electrons, the protons, and neutrons. So we have the protons and the neutrons in the center of the atom. And the protons, of course, are positive, pro for positive. Neutrons are neutral, and those are both housed in the center. And then we have these electrons swinging around the outside of the atom. And just to give it kind of a perspective as far as the size of the atom, you would have, for instance, the protons at the center, protons and neutrons at the center of a baseball field, let's say at the pitcher's mound, and the electrons would be swinging around the outside of the arena. So that really gives you a better idea of the size scale of an atom. Okay? And then if we take a look at also some more of these chemical topics or chemistry topics that are of importance, understanding electron shell diagram, or how to draw an electron shell diagram for the first three orbitals really is where we're going to be focused with biological molecules. And you know that 2 electrons can fit in the first shell energy level, and then up to 8 in the second, and then also up to 8 in the third. We won't get into FD kind of or S orbital designations. It's really beyond the scope of our course, and it's more pertains to a chemistry course. But for our purposes, that's where we're going to stay, and that's where that's the extent of the information I need you to know. And then just to provide a short example, if we take, for instance, oxygen, and we draw the electron shell diagram, we will see that we have, in our first shell, we have our 2 electrons, and then in our next shell, we would have 1, 2, 3, 4, 5, and 6. How did I know that? Well, the atomic number for oxygen, it's 8. And the atomic number is the number of protons. So 1, 2 in the first, 3, 4, 5, 6, 7, and 8. That leaves us with 2 unpaired electrons. These electrons, not so happy, not so happy. So they like to pair up with other electrons. They like to be in pairs. That's how they're most stable. So this atom by itself is hungry. It's hungry for electrons. So atoms will share electrons, or they can donate electrons or receive electrons, just depending on what is needed and what atoms are involved. So if we take, for instance, hydrogen, atomic number 1, all right. These 2 can share. When we share, we have a covalent bond. Okay? And we still have one over here, it's hungry. So we can provide another atom of hydrogen, let's say, and these 2 guys can share. Well, share and share alike. It's beautiful. All right. So now everyone is happy because the hydrogens have 2 electrons, each of them filling that first energy level. The oxygen now has these 2 paired up, sharing that electron from the hydrogen. It's a happy, happy world, and it makes a beautiful molecule, oxygen and 2 hydrogens. Water. And water is wonderful. Yes, it is. Okay. So we'll discuss water as well as a molecule and the wonders of water. I can't even tell you. Well, I could, but. Now, when we take a look at water, we want to think about the electrical charges associated with water. So just by the water molecule itself, like we had explained, the properties or the sharing of electrons going on with the oxygens and the hydrogens, it sets up a situation where we have partial positive charges on the hydrogens and partial negative charges around the oxygen. Because the oxygen has a greater pull on the electrons, those shared electrons we talked about and we drew up here on the board. A greater share, a greater pull on electrons than the hydrogen atoms. So as a result, those electrons spend more time around the oxygen than they do around the hydrogen. It's kind of like everybody, likes the oxygen. And when I say everybody, I mean the electrons. The electrons they're just got of the oxygen. And the hydrogens, not so much. So we have this situation where, again, the electrons are spending a lot more time, those 2 shared electrons from the hydrogen are spending a lot more time on the oxygen and spending less time around the hydrogen. And of course, electrons are negatively charged. So as a result of the electrons spending more time around the oxygen, it sets up a situation where we have partial negative charges with the oxygen. And as a result of those electrons, again, staying closer and spending more time around the oxygen, we have a situation where we have a partial positive charge associated with the hydrogen. Okay. So again, this is very, very important to understand this concept of partial positives and partial negatives around these atoms. And as a result of these partial positive and partial negative charges that we see with the water molecule, it sets up a situation where we can have properties emerge from many water, or as a result of many water molecules coming together. So when water molecules get together, they can bond through a special bonding called hydrogen bonding that leads to several emergent properties of water. And if it were not for the water molecule and its electrical charges, partial positive, partial negatives, and how that sets up an interaction among the water molecules in liquid water and frozen water and water vapor, life on this planet would not exist. So this is really kind of a throwback to our first chapter when we talked about emergent properties and this understanding that we have, again, partial positives and partial negative charges associated with this water molecule.